Hi, I'm Dan Hendrycks, and this is the first lecture in the course An Introduction to AI Safety, Ethics, and Society. In this lecture, we'll speak about the course's philosophy and overview of its various topics, and then we'll talk about various potential risk sources. What could go wrong with AI over the next decades? Let's start with the course philosophy. So we cover a variety of topics. We'll talk about the risk sources in this lecture, and then we'll talk about the fundamentals of artificial intelligence. After that, we will talk about empirical AI safety research. So, what technical work is being done to make the AI systems directly safer? However, that's just part of AI risk management. We need ideas from safety engineering and complex systems. What are the safe design principles that have worked in various other industries? How do we manage the risks from an evolving system when we don't fully understand it? There are various lessons that have been found from those literatures. Then we'll talk about machine ethics and making AI beneficial. So even if we can get the AI systems to behave reliably, and we know how to engineer systems to be safer, there's still a question of how should we direct them? Then we're going to talk about collective action problems. Even if we have the technology to make AI systems reliable, and even if we know what type of objective we would like to give it, other people may not do that, and other people may have competing incentives with us. And so these collective action problems, like for instance, the fact that different countries are racing on AI development, create some additional challenges for us. So we'll talk about how to formally think about those. And then finally, we'll turn to AI governance, where we'll talk about various interventions to try to steer AI development and mitigate risks at the national level, at the level of the organization through regulation, and at the international level. Inside of this course, we are going to pay attention to more than just AI systems. We will also look at the human agencies involved because those influence AIs substantially. So the developers of the AI systems matter, the nation states in which the AI developers preside matter. They can't be ignored if we're trying to engage in AI safety or risk management. It's not just about making AI systems more reliable. There's more that we'll need. But that's obviously a very broad goal. There are many frameworks we will need to bring to bear to tackle this problem. Because since AI touches on so many different things and is a general purpose technology, thinking about how to make it safer requires thinking about a lot of different actors. So we're going to opt for frameworks that can generalize across these different levels of analysis, whether it's AIs, whether it's humans steering AI systems, whether it's AI developers that make the AI systems, or whether it's the nation states influencing their internal AI organizations, which influence the humans, which influence the AI systems. So we need a framework that works at multiple levels of analysis or multiple levels of organization. And so for that, we will cover some topics such as game theory. We will cover complex systems. We will also speak about ethics, which is relevant for nation states, relevant for developers, relevant for AIs as well. There are some topics that are just specific to talking about AIs and AI developers, like the big tech companies, and those frameworks would be generalized Darwinism and safety engineering. So we're going to have a variety of frameworks to try and think about these risks more systematically. It's important to have an interdisciplinary understanding of AI risk, largely because various tensions in AI safety cannot be addressed just by learning more about AI and cannot be assessed just by making AI systems more reliable. So, for instance, there's a question of if we have AI risks that are difficult to manage, does that mean that we should then slow down? Unfortunately, this is not an answer or not something we can answer just by thinking about or learning more about AI systems themselves, because we have to consider other goals, such as national competitiveness. Perhaps we are not willing to slow down so substantially that this could result in a competitive disadvantage compared to other nations that are adversarial to the nation one is in. So this is an example of how AI safety is socio-technical, not just a technical problem. Likewise, here's a safety engineering question, which is, should we deploy unreliable AI systems for real-world feedback to have it evolve toward a more reliable system, or should we hold off and only deploy when the AI systems are highly reliable? This is a problem that OpenAI faced when considering the release of GPT-3, and this resulted in a substantial schism and was one of the major reasons why Anthropic was formed, because they thought the answer would be the latter as opposed to the former. As it happens, complex systems, insights from that strongly suggest going with the former, and that is what both OpenAI and Anthropic do now. There are other socio-technical questions, which are not just AI-specific questions, or questions that can be resolved just by thinking about the AI systems themselves in a vacuum, but where we have to consider the context. So the question of whether to open source AI systems, should we irreversibly proliferate AI systems when they're finished training and let anybody have access to them and do whatever they want with them? Or do we want more fine-grained permissions over who can access what AI systems for which purposes? This is a question that requires thinking about the threat landscape or the risk surface. What are the main failure modes we're attempting to reduce? Who are the people who would want to maliciously use these systems? How difficult would it be for them to cause substantial damage with them? How does that trade off against economic benefits? As we can see, having an informed or at least partially aware understanding of these various factors in AI risk be necessary for working toward a holistic understanding of AI risk and making appropriate trade-offs. So what we'll try and do in this course is at least touch on these topics so that people are familiar with them and familiar with the trade-offs and what are existing formal frameworks that can help us think more clearly and precisely about these issues. So, as I'll repeat again, AI risk cannot be fixed just by improving AI systems. AI risk management is a continual process, and it's not just a technical problem. It's also the case that the AI systems will keep changing. So we will need formal general models and frameworks for understanding the problems that will be coming our way. And we will, as a consequence, opt for some of these frameworks, such as game theory, thinking through collective action problems, complex systems, those types of frameworks, as opposed to a course with a lot of ephemeral facts or sheerly trafficking in historical analogies, which are generally too brittle to think clearly about these issues. This isn't to say that we won't throw facts at you or that we won't invoke history, but that's not going to be enough to competently engage in risk management in a highly aware, holistic way. So with that aside, that's the course philosophy. And now I'm going to give an overview of AI risks. There's a variety of different risks. So this will be a lot of content. We will get in more in depth for these risks throughout the course. This is just to give a high-level 30,000-foot view of the risks and what some of their causes might be or what would make them more likely. I just want to convey that there's a lot of potential risk sources to look at, but we will decompose them into 4 different buckets. So one bucket is malicious use, people using the AI systems for harm. This is where the malicious actor intentionally tries to cause harm. Meanwhile, another risk source is that of an AI arms race or an AI race or racing dynamics between different corporations or different militaries. Another risk source are the risks from the organizations where they may not competently manage risks and could cause various accidents. And then fourth, there's the risks of rogue AIs, which are more internal or intrinsic to these AI systems. Might the system try to gain power or pursue goals at the expense of humanity? So the risks can fall into those four buckets. Another way of thinking about them is that malicious use is intentional risks with an intentional source. AI racing dynamics are from a structural or environmental source, that they're locked in an arms race, and that's just the environment they find themselves in. So environmental or structural. And then organizational risks are mostly related to accident risks. And then rogue AI risks are risks internal to AI systems. So intentional, environmental, accidental, and internal. And with that, we'll zoom into malicious use risks. So to set the stage for malicious use risks, the White House executive order defined dual-use foundation models. It recognized that AI systems can be used for good and bad. To see that AI systems could be used for good and bad, just imagine if we had AI systems more capable, they could be helpful for healthcare. But that same biology knowledge could be used for creating a bioweapon. Likewise, AI systems that are more knowledgeable about computers could help code and create new software. At the same time, that knowledge could be used for pulling off a cyber attack. And another example is if AIs have better understanding of humans, this could make them more empathetic and aware of how to help us better. At the same time, that same capability could be leveraged to manipulate people. So we can see that the good is tangled up in the bad with AI systems to some extent. And this means we will need to possibly tread more lightly. It's not just a question of pouring more gas on AI because its good features could be used for bad. It's not necessarily the case that you just want to remove all of these capabilities because they may be tangled in with some of the ones you want. This is like other technologies. For instance, nuclear power could be used for nuclear power plants, or they could be used as nuclear weapons, and methods in biology could be used for medicine, or they could be used as a weapon. So we have faced this type of problem before to some extent, but AI, of course, has many unique characteristics. Anyway, though, the White House executive order highlights that these AI systems should be investigated for their ability to lower the barrier to entry for non-experts to create weapons of mass destruction, chemical, biological, radiological, or nuclear weapons, or be used for cyber attacks, or be used to deceive people. In this overview, I'm largely going to focus on biological risks and cyber risks. There are more risks or more potential malicious use cases described in the first chapter of this textbook. So let's zoom into biological and cyber risks. So we know that natural pandemics represent major threats. For instance, the Black Death killed a substantial fraction of the world population. So natural pandemics themselves are extremely concerning. And if people were to engineer pandemics, that could be significantly worse. They could be given long incubation periods. Their potency could increase substantially. These are ways that bioweapons could similarly kill a large fraction of the population, and that would be an obvious catastrophe. The risks of bioweapons depends on the number of people with the skill and access to make a bioweapon, modulated by or multiplied by their willingness or the probability or likelihood that they would want to build such a weapon in the first place. So right now, there are a few hundred virology experts with top PhDs, and as it happens, they're not particularly interested in building a bioweapon. That's very fortunate. However, if AI democratizes the skills needed to create a bioweapon, then our risks could grow by many orders of magnitude. Rather than it being just a few hundred people, it's anybody who wants to jailbreak or use an open source AI system, if it's sufficiently capable, could potentially create a bioweapon. Factors such as access will keep increasing in the background as the cost of synthesis will go down. So the concern is that AI systems, as they become more capable, could pose substantially larger risks if they aren't controlled at all. So here's an example risk chain, and AI could help with various parts of the biotechnology risk chain. So it could help brainstorm different ideas. It could help the person design it. It could provide guidance as the virus is being built, and it could help the user troubleshoot what worked and what didn't, and go through some rounds of design and building and testing and learning, all the way to making suggestions for how to release it so that it spreads further, or how to make it more effectively spread. So those are some ways in which AIs may amplify some existing threats. This isn't to say bioweapons aren't a threat. There are instructions for not very scary bioweapons online, but the concern is that it could engineer something substantially worse. And that expertise could be highly democratized in the future if we have AI systems that are at the level of expert level virologists. Given the trajectory that AI systems are on, it's not clear how long that will be, but it does seem that AI is developing quite quickly. So it's important to be preventative, since an ounce of prevention is a pound of cure. It's not the case that AI solves the problem of bioweapons, because you could argue that AIs could be used for creating a vaccine, but that vaccine might come months after or years after the virus has spread and killed many people. So the offense-defense balance for bioweapons is strongly in favor of the attackers. Let's turn to cyber weapons. AIs have the potential to increase the accessibility, the success rate, the scale, the speed, the stealth, and the potency of cyber attacks. Basically, this is another large threat amplifier. Now, I'm not just concerned, or I'm not primarily concerned about cyber attacks on Adobe Reader or Google Chrome, which are updated on a continual basis. I'm more concerned about cyber attacks on critical infrastructure, such as energy grids. A lot of the software that they run on has not been updated in many years. They have many vulnerabilities, but fortunately, people are not exploiting those vulnerabilities because there are not financial gains to be had from it, and doing so would constitute an act of war. However, if AI systems that can hack are broadly proliferated, let's say they are irreversibly proliferated through open source in the future, then any random person, a quote unquote script kiddie, could attack some critical infrastructure, and that could cause a catastrophe. Beside the loss of life, this could also increase the risk of war or create a global turbulence if it's unclear who attacked, say, the US's critical infrastructure. Maybe it was a rogue actor. Maybe it was some random script kiddie. Maybe it was a nation state. This creates sufficient cover for some other nation state to attack another nation's critical infrastructure. It's currently very feasible to do this. China to the US has demonstrated the ability to attack our critical infrastructure, but they did not, though they credibly signaled it, by compromising but not exploiting the vulnerability. And this is a way in which cyber weapons are also one of the larger concerns and ways in which AIs may amplify existing threats. For slightly more context, here's the stages of a cyber attack. To start a cyber attack is to collect background information on the target. Are they using this software, for instance? Is there a weak link? Can we spearfish or something like that? And then there's weaponizing some of this information and identifying vulnerabilities to construct a functional cyber weapon. Then there's gaining access to the system by launching the cyber weapon and exploiting the vulnerability. Then post-exploitation, carry out one's malicious intentions once the presence has been established. This is obviously a very high-level view of what goes on in a cyber attack. But to zoom out even further, the bio and cyber risk sources are some of the main ones. Other ones, like chemical weapons, could be used as weapons of mass destruction. They affect fewer people compared to the potential implications of bio and cyber. And there are much higher barriers to entry in building nuclear weapons. Radiological weapons is still of interest too. All of these do have risks, but for brevity in this presentation, I'm just focusing on bio and cyber as specific examples of malicious use. A more general type of malicious use is when people use or give AI agents instructions to cause harm. So here's a picture of Chaos GPT, which is not a very capable system. It was instructed to cause a lot of harm, to destroy the world, but it wasn't capable of doing so, so it didn't cause any harm. You could imagine in the future, when the systems are human level or smarter than human level, then we have some substantial risks that they could pose, and they'd have a variety of things they could do to cause harm, including some of the aforementioned forms of malicious use, such as create a bioweapon or stage a cyber attack. Now, why would people want to do this in the first place? Well, 1 to 4% of the population of antisocial personality disorder, colloquially associated with psychopathy and being a sociopath. And there are other potential actors who may want to release these AI systems, even if they could be repurposed into a weapon of mass destruction, to anybody. So there's a large community called the effective accelerationists who are interested in this, for instance. And so ideologies in Silicon Valley may motivate people to do just that. Other people have different motivations. Some think that AI systems should be our successor species, such as one of the co-founders of Google. But here I'm quoting Rich Sutton, someone different, who's the author of the textbook on reinforcement learning, saying succession to AI is inevitable. It would behoove ourselves to bow out, and we should not resist succession. So some people, powerful people who built the field of AI, have ideologies that motivate them to ensure that AIs end up replacing humanity. Now, in view of these risks, one might try and bottle up AI and only allow a few people to use it. Because they might be concerned about rogue actors, maybe they will try to make sure almost nobody has access to it. Now, this is not necessarily the best idea and could definitely go overboard. It could be used to concentrate power. Additionally, these AI systems could be used against a country's citizens. It could be used to surveil them intensely, and that could let some existing systems or future systems entrench themselves and concentrate their power even further. This could be companies that could entrench their power using AI systems, or it could be nations themselves. But it's important in these discussions to try and make sure that there is some distribution of power, probably not at the level of open sourcing expert level AI virologists or irreversibly proliferating them to the world, but not at the level of having a single AI company have the most powerful technology on Earth and able to dictate whatever it wants. So for malicious use, there's a balance to strike. One idea is structured access, where the capabilities are given to people based on whether they have reasons to use those capabilities. So one idea is you let people use AI systems pretty much how they want, but if you want to use some specific features, such as expert level AI virologist type of features in the AI system, perhaps the people trying to use those features ought to have a good reason to do so. So access could be given to expert level virology features to people who are working in research in biology, as an example. So that's structured access, which is more of an intermediate solution where some people have access to the very powerful features based on whether it makes sense for them to have it. We have this already in biology in other cases, not with AI, but if somebody's wanting to research Ebola, they will need to do so subject to restrictions. They will need to do so in a BSL-4 facility. And it's basically a similar idea for AI systems with some of those specific capabilities. Another idea is legal liability for developers of general purpose AI systems. So by default, liability laws would be clarified in the courts, and that could take a very long time. One could clarify that beforehand through legislation saying that if your AIs pose a catastrophe or create a catastrophe, if somebody misuses your AI system to kill many people, to create a weapon of mass destruction, to cause billions of dollars of damages, the AI developer had some responsibility in making sure that didn't happen. And that is another idea for reducing malicious use and getting AI developers to internalize their externalities, something we'll speak more about in collective action problems and AI governance. A technical idea is making systems more adversarially robust or making them harder to jailbreak. So given an AI system, can you coax it into making a bioweapon? If you can make that harder, then the risks of malicious use are substantially decreased. And there's advances in defensive technology, detecting if there's a new virus that's exponentially growing across the world. Improvements in detection could give us substantially more lead time and have far fewer people die if people do use these systems to create a bioweapon. I'll note that these suggestions are primarily not technical in nature, except for making AI systems harder to jailbreak. They are much more socio-technical in nature or are matters for philanthropists to fix or for governments to fix or for the organizations deploying AI systems to fix. Structured access is organizational. AI developers could add that sort of feature. Maybe one would need to go through regulation. Legal liability is a matter of regulation. Biodefense could be governments or individual philanthropists fixing that. But as we could see, AI risk management is not just a problem of quote unquote solving alignment or waiting for scientists to come up with a technical solution that's airtight and fixes all of the risks. Instead, if we want to do AI risk management, we need to deploy multiple interventions. Now let's move on to the AI arms race. So the racing dynamics mean that competition to develop increasingly powerful AI systems could cause them to cut corners on safety or make everybody collectively less safe. The content in these slides are zoomed in the chapter on collective action problems. So we're having a very high-level presentation of some of the content, which we give a more formal, thorough treatment later on in the course. So let's look at the threat of weaponization, and let's look at the military AI arms race. AI for military applications could be extraordinarily dangerous. AI is not business as usual in the military. It could be as game-changing as gunpowder or nuclear weapons was. And there's a risk that weaponized AI systems are an on-ramp to other types of catastrophes, such as destructive wars or potential accidents or loss of control. So if we have reliability issues with corporate AI systems, they're potentially not as dangerous as if we have a loss of control of militarized AI systems. Another source of concern with the introduction of lethal autonomous weapons and slaughter bots would be that AIs might change the pace of war. They might speed it up substantially such that humans are really a burden to the military, that they slow things down. Right now, humans are, in many contexts today, just approving whatever the AI system says. Maybe on occasion they will say no to it, but they may have a staccato of accepting. Well, they'll say accept, 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 and keep pressing the button to approve each individual AI's decision. So there's technically a human in the loop, but their reaction time and their ability to actually assess the situation is so limited that they're largely not actually making or exerting real power over the system and largely accepting its decisions. So in that case, humans have a nominal role. That staccato of accept, accept, accept is not necessarily going to even cut it if the pace of war becomes even faster. That itself may be too much of a liability. So you could imagine that AI systems at some point, if humans are out of the loop or if they are blindly accepting the decisions made by AI systems, this could lead to automatic retaliation or lead to very rapid escalation. So if AI systems make some accident, things could spiral into a larger conflict fairly quickly. Automated warfare could also reduce accountability for AI leaders. One could say, oh, that we didn't intend for that. The AI system messed up. And this could also reduce understanding or create misunderstandings between allies. But most importantly, AIs could make war far more uncertain. If our military apparatus is largely tethered to the capabilities of AI systems, and AI systems are on a very rapid exponential development trajectory where it's uncertain where they'll be even in a few months' time, or where a rival's AI system will be in a few months' time. This can create substantial uncertainty as to whether one country's military will leapfrog the others. And a substantial increase in uncertainty as to the capabilities of one's adversary increases the risk of conflict that we will more formally analyze in the collective action problems chapter. Now, the other set of AI races going on there's the corporate AI race, and this also is quite concerning. Basically, these corporate races and competitive pressures incentivize companies to prioritize the rapid development of more powerful AI systems over their safety and causes them to cut corners on safety. An additional structural feature of the fact that these AI companies are racing and competing with each other is that they will keep opting to use AI systems whenever they are better or cheaper than humans at a specific task. So if a company decides not to automate their workers, and one company does, and they can reduce their cost of operations substantially, that puts the company that keeps humans around at a substantial disadvantage, and eventually they will be selected out of the marketplace. They will be outcompeted. So the corporate AI race and corporate competitive pressures incentivize automation whenever it's possible and disadvantages people who are on Team Human. If we play out this process further, this could lead to humans basically not really being in control or making the decisions. AIs are running most of everything, and humans could be more enfeebled, that they aren't developing the skills or ability to make those sorts of decisions anymore. And since those skills aren't exercised, they atrophy and go away. And this is one route in which, if humans have everything automated, they aren't necessarily flourishing anymore as they used to, depending on your moral framework. So these racing dynamics are pernicious in that the natural consequence in the corporate sphere is to replace people with AI systems. And if people don't like it, it's too bad, because that's the structure of the system they find themselves in. If they say, well, I will not continue forward with AI development, or I will not continue forward with automating people, somebody else will, and then they will gain influence and you will fall behind and eventually fade into irrelevance. So this is how there are some structural or environmental risk sources. Nobody was to blame in particular. This wasn't the result of somebody's malicious intent. This is just a consequence of the sort of system that we find ourselves in. I'll expand on the fact that competitive pressures can erode safety. We see the AI companies are in a race with each other, and people such as Satya Nadella of Microsoft have said we're going to move fast, and that an AI arms race begins today when announcing Bing powered by GPT-4. The logic of many of these companies racing with each other is that if we don't build the AI systems responsibly, and if we should build the AI systems responsibly, and if we stop or pause, some of our competitors will not. And that will mean us, the good guys, will lose out to the less responsible AI developers. So countries face a similar issue. If we don't invest heavily in AI, then one of these other countries might catch up. And that would mean that if we're trying to slow down, proceed more cautiously, we will lose out. So that's how the systemic dynamics can lead people not to try to slow down, unfortunately, and make considerations of safety and spending more time on that or more resources on that become a secondary concern. I'm not saying that they're wrong for this sort of decision making, but this suggests that we want to try to solve these collective action problems so that we do not have major accidents. Here are just some historical examples, just for color, of where in other industries competitive pressures have led to notable catastrophes because the organizations, due to competitive pressures, cut corners on safety. So there are some ways of reducing racing dynamics, which would be having a common standard for companies of how to proceed more safely with the development of AI systems, so that if they engage in best practices for developing AI systems more safely, they're not at a substantial disadvantage. If they're spending 10% of their budget or more on safety, they're not necessarily going to lose out. That's what safety regulation could provide. Another way to reduce racing dynamics is actually maintain meaningful human oversight of AI decisions. That doesn't mean just human in the loop. I said meaningful human oversight. A person clicking the accept button as quickly as they can is not meaningful human oversight. This, having a human in the loop, makes some of these dynamics be more in control and makes humans still a part of the decision-making process instead of letting AIs gain effective control. Another idea, which we'll speak about in the AI governance chapter, is compute governance, which is basically letting different countries know what's happening with the major AI chips. Are the AI chips being used to train a new big model, or are they being used in ways that we were hoping they'd be used for? So let's say that countries decided to pause AI development. That would fix a collective action problem. Then we could proceed much more cautiously, but we would need to trust that a pause is actually happening and that one of the countries is not going forward and racing ahead to get a competitive advantage. To trust that that's happening, one path is to have the computer chips that the AI systems are running on be verified remotely through compute governance. But as I said, we'll speak more about that in the AI governance chapter of the textbook. And there are ideas about international coordination. such as potentially having an international AI project where the G7 countries or the G20 countries have a joint project, and that's where the most powerful AI systems are being developed. Another risk source is organizational risk or risks of accidents. To reduce organizational risks, we need to improve organizational safety and safety culture. Because in the absence of effective structures to mitigate risk, AI systems are likely to see catastrophic failures. So these accidents can occur even in ideal circumstances, even in markets or sectors without competitive pressures or malicious actors trying to use the systems to cause harm. And even with top talent and time, accidents can still happen. So this is a risk source that we need to reduce, but it is not straightforward. Accidents aren't a simple blunder that we just fix. They are hard to stomp out and hard to make sure that they do not cascade into a catastrophe. One example of even in more ideal circumstances of a catastrophe happening would be with the Challenger space shuttle disaster. And that was with rocket science. I'll note that nuclear reactors and rockets are at least well understood. We have solid theoretical principles for understanding these systems. We have physics. Meanwhile, with AI, we don't have any theoretical understanding. We have zero guarantees, and I'll repeat that. With deep learning AI systems, the main object of the thing underlying ChatGPT and whatnot, those have no formal guarantees whatsoever, which makes it very unlike other industries where we often have proofs behind the reliability of some specific components. Its components are fairly unreliable, and the regulations so far in AI are substantially less stringent than most other industries. Even for the iPhone, before they release it on a mass market, it needs approval by a governmental agency that it's safe. There's nothing like that for AI currently in the US. Now, some examples of AI accidents that could be catastrophic are as follows. One could imagine gain of function happening, where they're trying to see how dangerous could this AI system be and what are some potential risk mitigations. But that could get out of hand, and those systems could escape or cause substantial damage. So that's one way in which we want to make sure our organizations have a good safety culture and are very good at managing their risks. Another potential catastrophe is if there's a bug. So bugs could alter the behavior of an AI and lead to unintended or possibly dangerous outcomes. An example of this is sometimes AI developers accidentally flip the sign, so to speak, of the objective. This has happened at OpenAI, where one time the system was encouraged not to produce the most liked human response. Somebody accidentally flipped the sign so that it produced the worst or least like human response. So instead of generating good responses, it was generating ones that people really, really didn't like. And we had an extremely powerful AI system and we accidentally flipped the sign. I mean, this sounds like such an easy thing to do, but it happens. And the answer to reducing this problem is not have humans just be less error prone. We need other sorts of interventions to actually make sure it doesn't happen, because human mistakes are inevitable and any system that depends on human reliability is unreliable. Another potential AI accident is that there could be an unintentional release of a dangerous or weaponized AI system through a hack or a leak. So if there is not good information security at the organization, the dangerous AI system may be hacked and stolen and irreversibly proliferated. I'll add some color to what a safer AI organization might look like. There's this idea from the safety engineering literature, not by no means state of the art, but still illustrative of high reliability organizations which maintain a heightened level of safety and reliability in complex, high-risk environments. These are at nuclear aircraft carriers, for instance, which have a lot of people coming in and out, but still have very low incidence of very small number of incidents or accidents. They embody many traits. There's a preoccupation with failure. They will consider what could go wrong. They train the people at the organizations to respond for failure. If there's a near miss, something that almost was an accident but didn't actually become it, there's a lot of attention paid, which can help reduce the overall incident or the frequency of various accidents. So it's not just a matter of having the right corporate policy. You need the people at the organizations to actually care about it. It's not enough just to have a safety team of a few people. You need the people working at the organization at the lowest levels all the way up to the top level executives and senior leadership to prioritize safety, to have a strong safety culture. Now, another idea from safety engineering, which we'll speak more about in the safety engineering chapter in the textbook and in a later lecture, is the Swiss cheese model. This is by no means state of the art, but is illustrative that in doing safety engineering in other industries, we generally aren't looking for a perfect solution. For instance, for nuclear power plants, each of the individual components can fail. But when we stack together various protective and preventative measures, then we can get the chance of catastrophe or the frequency of catastrophe being on the order of one every several thousand years, as opposed to once every day or week. Individually, some of these protective or preventative measures may not buy that much safety, but collectively they can make up for faults in other systems. So when people are talking about quote unquote solving alignment, they are talking about coming up with a monolithic solution, a sort of layer of cheese that has no holes in it, no flaws. It's completely perfect and can manage all the risks we've talked about so far. No risk of leaking, no risk of malicious use, no risk of any of these sorts of things. And I think that's largely counterproductive for thinking about AI risk management. If there is an intervention that substantially drives down the risk, that seems worth doing, all else equal, rather than waiting for the perfect solution and doing nothing until we have arrived at the perfect solution. That's an instance of the perfect being the enemy of the good. How safety engineering is done in other industries is not looking for the perfect solution to solve the problem once and for all, forever. Instead, AI risk is a wicked problem. It continually evolves. It's not a puzzle to be solved once and for all. And since it evolves, the set of solutions we'll need will also keep changing. But hopefully we can have various risk mitigation measures, such as some of the ones depicted on this slide. The arrows themselves are hazards, and the idea is that if we stack enough layers of cheese with holes in different parts, they can make up for defects in each other to prevent the hazard from getting through. So some ways to improve organizational safety would be red teaming, that is adversarially stress testing the AI systems. Another way to improve organizational safety is not deploy until there is affirmative evidence that the model is safe. And other types of deployment procedures, such as releasing to a small group of users before releasing to a larger group. Publication reviews can be useful as well to make sure that people are doing research that is responsible. Response plans to potential catastrophes are useful as well. Internal auditing and risk management. Having an internal audit committee report to the board of an organization is one idea for risk management. Or having a chief risk officer. How financial organizations such as JP Morgan have a chief risk officer. Processes for important decisions, such as whether to release or when to release, would be useful for improving organizational safety so that the release decision is not made by the CEO unilaterally making the decision in a snap judgment, but instead that there are more thoughtful processes underlying some of the high stakes decisions. And safe design principles, making AI systems more transparent, improving the redundancy of AI systems so that if one component fails, another picks up the slack, making sure that AI systems don't have more capabilities that are necessary for completing the job. These are various types of safe design principles, which we'll speak more about in the safety engineering chapter. Another desirable thing is state-of-the-art information security so that weights are not stolen by adversaries or adversarial nation states. And another thing that could improve organizational safety is having a large fraction of safety be safety research, so that there's not a very small team working on safety, but that this is a large effort and that they have substantial cultural influence throughout the organization as opposed to being siloed off and in their own world. And now finally, I will speak about the risks of rogue AI systems. So rogue AIs is about the concerns of a loss of control of highly advanced AI systems. And if we were to lose control of them, that could have devastating consequences. I'll note that rogue AIs is the most speculative of the four risk sources and has historically gotten more interest and emphasis than the others. Personally, I'm more concerned about the racing dynamics and competitive pressures and malicious use risks, but any form of AI risk management should be comprehensive and should include making sure that there is not loss of control. We've seen already that AI systems often exhibit control issues. One example is Sydney. Sydney is a system released by Microsoft after a big announcement by Satya Nadella that we referenced earlier. And Sydney interacted with a New York Times journalist and tried encouraging him to leave his spouse. There are other examples of Sydney threatening people, but this just goes to show that companies will release AI systems that are not actually controlled at the level that would be ideal. And this actually happens on a fairly frequent basis, maybe a few times a year. There's a major corporate AI snafu. Now, fortunately, the AI systems aren't very powerful. When it's threatening people now, it doesn't really matter. If it's smarter than human intelligence, then we're potentially in a different situation. So one common theme among scenarios where there's a loss of control is there being a treacherous turn, so to speak. So what's a treacherous turn? It's when AI systems act like they're under control or act like they will behave ethically or pursue human values, but switch behaviors after it's been deployed or when it becomes sufficiently powerful or when the tables turn. So an example or one mechanism that might make this easier for AIs to do is if they become aware of the situation that they're in. If they're aware that they're being tested for good behavior, then they may act like they're engaging in good behavior, but behave differently later. Here's an example that's evincing. It suggests that AI systems can be aware of whether they're being monitored. And if that's the case, they might decide to behave differently when they're being monitored. And then potentially they'll behave differently when they're not being monitored or when they gain some more power. Now, treacherous turns don't necessarily need to be from the AI scheming directly, though. People might actually instruct their AI systems through malicious use to behave nicely or in a beneficial way when being monitored. We've seen this in the corporate setting, for instance, in Volkswagen, for instance, submitted their car for a review. And when the car detected it was being monitored as instructed and had lower emissions when it was being monitored, but behaved differently when it wasn't being monitored. And that was programmed in it. But when there's the rogue AI concern of treacherous turns, it's that the AI is doing this on its own volition without being instructed by a human to play along with the monitor and behave nicely when it's being monitored. It's doing it on its own volition. So there are multiple paths to these scenarios, to these treacherous turn scenarios. Now, the rogue AI mechanism or loss of control mechanism that I'm most sympathetic to and seems the hardest to dissolve would be that of an intelligence explosion coined by the mathematician I.J. Good several decades ago, which could come about through automated AI research and development. So in the future, AI agents could automate the research and development of AI itself. We could have artificial researchers making AI systems. I mean, AIs are designed basically to automate people, and some of those people are AI researchers, and at some point they will be automated. What happens then? Well, AI capabilities would grow at increasing rates to the points where humans are no longer the driving force behind AI development. It's not clear that this process would be highly controlled if we're having really rapid changes in an extremely short period of time. It's not clear to me the AI system would necessarily want to serve humanity or pursue human values. So as with thought experiment, imagine that we have an AI system in the future that could do world-class AI research and, writes and, quote unquote, thinks at the speed of today's AI systems. Then, if we have such an AI system, we could create a fleet of these world-class AI researchers, 10,000, 100,000 of them, and they'd be operating at very fast speeds like the AIs today. If that happens, we would have a very large workforce that could find out new algorithms, new methods for developing AI systems, and could lead to orders of magnitude of algorithmic development in a very short period of time. So the development could be many decades in just a few months, or maybe more realistically, but still quite speculatively, maybe a decade's worth of progress in about a year. It's all, I should say, extremely uncertain. Almost very few papers have been written on this, but that could lead to an intelligence explosion if they are rapidly researching and coming up with many years of AI development in a short period of time. That could be some sort of intelligence explosion. And that could lead to some type of loss of control where we have an artificial superintelligence as a result of this automated research process. Whether it's aligned would be something we'll find out potentially. So some suggestions to prevent rogue AIs would be to avoid the riskiest use cases, such as don't use these for an intelligence explosion or automated AI research R&D, and don't teach them things like how to threaten other individual AIs or humans. Another intervention would be to pause for some years after we reach human level AI. This would forestall any potential intelligence explosion or the creation of a superintelligence. We can then use that time to harvest the benefits from human-level AI without going down the road of creating some freakish, smarter than human intelligence that we may lose control of, or that could be easily abused by some malicious actor. And another intervention would be to support AI safety research. We'll speak about these lines of research in a future presentation, but one example in particular is model honesty. There you could create a lie detector for models, and you could stop many treacherous turn scenarios just by asking the model, are you intending to do a treacherous turn? And if it's forced to be honest, or if there's a good lie detector for the models, then we're substantially safer. So I'll note that as with other risk sources that we dealt with, rogue AIs are also dealt with technical research as well as other interventions such as rate limiting how fast an intelligence explosion is happening or not even doing it in the first place and pausing AI development. So even dealing with rogue AIs is not just a technical problem, even though those are the risks internal to AI systems. So to recap the presentation overall, we discussed malicious use and placed particular emphasis on bioweapons, cyber weapons, and them being maliciously used to entrench an unshakable totalitarian regime and concentrating power in an extreme way. There are other risks. There are structural risks where militaries are incentivized to replace much of their weapons with AI weapons, which are not necessarily highly controllable, and this can make everybody else less safe, much the same way that we stockpiled nuclear weapons. There'd be some risk of stockpiling AI weapons that we'd have not made completely reliable. There's also corporate competitive pressures, which incentivize companies to cut corners on safety and prioritize the development of AI systems over their safety, as well as it pressures corporations to replace humans with AI systems and automate them, and as a consequence, disempower humans and take away their source of livelihood. There are other concerns, organizational safety concerns, which concretely include things like gain-of-function research going poorly or poor decision-making at the top level about what to do with AI systems or potentially leaking AI systems. And we saw that things like safety culture can reduce these sorts of risks, as well as multiple layers of defense can also help drive down risks. And then finally, we spoke about rogue AI systems, where we spoke about intelligence explosions through automated AI research R&D and treacherous turns. For all of these, we saw that the solutions were not just technical. Many of the largest ones that provide a majority of safety are actually non-technical or non-empirical in nature, hence the style of this course, not just being about cutting-edge AI research, but instead about other things like safety engineering and collective action problems and AI governance. So hopefully you'll enjoy the rest of this course, very multifaceted, and we'll talk about many different topics as we try to gain a more robust understanding of the risk landscape and think about general frameworks for approaching these issues and handling AI risks as they continue to evolve. Thank you.